Hi, welcome to 1.1 Moles and Molar Mass. I'm Tommy, and I'm going to help you learn about this stuff. Now, 1 mole is equal to about 6.02 times 10 to the 23rd particles, or Avogadro's number. Now, particles are basically anything. You can fit anything into particles, and it'll still work. Particles could be photons, it could be molecules, it could be formula units, but particles applies to almost anything. Now, we can use moles to get mass of anything from a given reaction or just get the amount of atoms that are in a certain item. Now, if we have 12 grams of carbon, how many carbon atoms do we have? So, when we look at a conversion problem and you look at the periodic table, you will see that each element has its own AMU unit. Now, an AMU, or atomic mass unit, signifies if I had a mole of this thing, how many grams I would have. If I had a mole of hydrogen, I would have 1 gram. If I had a mole of carbon, I'd have 12, a mole of nitrogen, 14, and etc. So if we have 12 grams of carbon, how many carbon atoms do we have? So what we need to do is set up some conversions. So we know that we have 12 grams carbon. Now we can multiply this by our molar mass, or the 12 grams per mole. So when you're working a conversion problem like this, always remember your units, because if we associate 12 with grams per mole, we will know whether to use the inverse of it or not, based off of what we can get grams to cancel out. In this case, we really do need grams to cancel out. So what we're going to do is we're going to take the inverse of 12 grams per mole. So we get 1 over 12 grams, 1 being 1 mole, of course. So when I put it like this, the grams will cancel out, and so will my 12s. And we will get 1 mole carbon. And now, since we have this 1 mole of carbon, we can now go from moles to particles, or in this case, carbon atoms. So we do 1 mole carbon times Avogadro's number, which is 6.02 times 10 to the 23rd carbon atoms, in this case, per mole. Moles cancel out, and we end up with 6.02 times 10 to the 23rd carbon atoms. So in this case, C. Now for molar mass, sometimes it's not as simple. Like with compounds, there's no thing on the periodic table that just tells you every single compound. So we're going to have to find ourselves. But luckily for us, it's very simple. So what you do is that you look at each atom in the compound and add them all up. So first, we have 6 carbons. So we're going to set up 6 times 12 grams per mole, plus 12, 1.00 grams per mole for the hydrogens. And finally, 6 times 16.0 grams per mole for the oxygen in the compound. And now we get a final total of 180 80 grams per mole.